I'm always trying to figure out how to move this little taskbar. Hmm. Okay, there we go. Okay, so yeah, thank you so much for joining. Last week we worked on collaborating, and this is really like the foundation for um, sharing code and then making your products visible online. And so we created a website uh, using GitHub Pages, and there were some issues that I haven't yet, apologies, fully addressed. I was traveling cross country and had a family reunion, but I see folks put in a bunch of comments in the notes, which is great. I also got a bunch of emails, and people created issues. So previously, in the slides, I had suggested multiple modes of feedback, um, including all of these options. So asking questions in the chat, raising your hand to speak, preferably after the first hour when you finish the demonstration mode, even adding comments into the slides. And this Google Doc where you can ask questions, and I see people are really helping each other out. And then there's sort of this, I'd say that this email is sort of, as far as tiers of awesomeness for feedback, email is up here, and then ultimately you want to try to start using these project management features. There's inevitably going to be issues, and unfortunately, with different operating systems, things vary between Windows and Mac and Linux. And if you have old versions of Git or RStudio or R, that can be a problem. And there could just be some lingering configuration issues. I expanded upon the collaborate lesson with some more essential tidbits, like I, oops, just lost my, so I added more tidbits in the lesson, uh, like what are RStudio and Git, and a little bit more on setting up Git and GitHub, and especially going into the RStudio. If it doesn't automatically find it, you might have to browse to the Git executable on your machine. It would be a git.exe. And then also referencing this happy Git and GitHub for the user, which somebody volunteered in the chat too, which is a great resource. So yeah, I got some emails, and then some people also launched some issues, which is really great. And let's just take a look over there. So we have some still open issues, but the beauty of this, and what I saw actually operative here was that there was some folks, even just screenshots are really useful. Any error messages you have are really useful. Anything that we can do to try to replicate your issue or problem, that's going to be useful in setting up an issue. And then folks even volunteered solutions, so you can look at past issues and then suggest to this community how to resolve it, and that got this participant moving forward, which is awesome, and introduced me to a new command. So I encourage you all to get into this habit of trying to document exactly what's wrong and moving forward. And what's interesting too is in the process of doing that, a lot of times you'll actually resolve the issue by kind of sequencing through. It forces you to define the logic of the problem. And then in that process, you might find the answer, often by Googling these error messages, ending up in Stack Overflow is a website where there's a lot of question answer response, and then seeing some proposed solutions. So that's the reality of these things moving forward. And I'm going to share, I've got some slotted times that I'm going to add for tomorrow, 8 to 10 a.m. Pacific time and 4 to 6 p.m. Pacific time, and then Wednesday, noon to 2. I was really wanting to avoid individual help, but I'm having a little trouble understanding where some people are stuck, and hopefully we can do a few of these and un, get people past whatever hurdle they're having with this initial setup, which is really obviously very key. So I'll email you shortly about that, those times, and uh, and then with these pull requests. So I'm just recapping on last week's lesson, then I'll move into this week's. But really, the idea was to go through these 3 different workflows of just a simple push and pull to exchange between your local machine and then getting your files on GitHub. And then there's a different model where if you don't have write capability on a given repository, like it's some open source R package, for instance, then you can actually suggest changes by forking, creating copy into your writable space, and then making changes that in that writable space, and then asking those changes to be done. And that's the mode that where we were able to update this little table, this comma separated value file, and then I re-render and we get all these, you guys start showing up with your GitHub username, your name, and then the link to where you've created your exercises website. So great progress. We've got, I've updated, I put myself in there, so 35 entries there. And we also have a few more pull requests that are queued up. So good job, everybody. That's really awesome. And then I just wanted to show you a little something else. The conflicts that you might run into, which are rare, because Git does actually a good job of merging different sections, even of the same file that people might be editing. But in this case, it happened pretty much every time because the original data file roster CSV, originally it just had this as the first line. And then so when you forked the copy into your space, it just had that first line in the CSV. And then when you made the pull request, other people, I might have merged other people in there. So I'll add some documentation to this, but I just thought this was an interesting learning experience for me in how to deal with all these merges and conflicts, because there's yet another Git client and that works well with GitHub called GitHub Desktop. And I'll just show you how that might work. So we can use GitHub Desktop to also handle these merges. So if I'm on the master branch, I can go and fetch this. And then let's say here I've got, these are all the pull requests that I see here. And I'll just start with the earliest one. And what I can do is switch to that pull request from this user, and it's going to go fetch. Oh, hang on. I just have to commit something first. Hang on. Let's see. What did I just change? I added some details. Knit that. Get it up. Update that. Push it. So I didn't yet have committed changes, but there's just something a little bit nicer about doing it this way. So I'm on my master branch, And now I want to take Dempsey Seamar's pull request and look at that. So it defaults to creating a current branch of PR43, which is that pull request. And don't worry, I'm going to document this. You don't have to do this for any of the lessons, but I just wanted to show you that this is another way to merge a pull request. So now I switch back to my master, and now I can choose a branch to merge into master, choose that pull request. It notices that conflicted file, create a merge commit, and now it's like, okay, it has this part where the head is, well, I can open this in a text editor called Atom, which is actually made by the GitHub folks. And with Atom, it does this pretty interesting, more user-friendly view where I can just say use me or use me and then you can see it's their changes, our changes. So so I can use theirs, then ours, and then that puts Dempsey's at the bottom. And I save that, and then I go back to GitHub Desktop, and now this conflict has been resolved, and we see that that file, that one line gets added. I continue to merge, and then I push the origin, and this now goes from an open pull request, if we click on it and see it, to a merged pull request. So I know that was a little kind of confusing, but GitHub Desktop just does a nicer job, especially working with Atom, to resolve some of those file conflicts should you encounter them. So that's just a little note. I'll go ahead and continue with those pull requests as you bring them in. And yeah, and I'll go through and share these, go through these notes in more detail, especially once I can meet with people more individually to resolve those issues. Okay, so with that, oh, and then I guess I just want to show you an example too of how these pull requests work in the real world. So I was to display these icons in the lesson, like here with these little clouds for the GitHub being online versus the local PC, and then these other little icons. I happen to use, I use this icons R package, and you can use all these different icons to include them in your Rmarkdown document. But there was actually a problem with the URL that changed for this Octacons icon set. And so I was able to fork this into my writable space, see the code where it went to the wrong URL, update that code, and then submit a pull request. So here's my pull request for this open source R package. And this is a quick fix to get it to work. And you can see the files that were changed. And this is why GitHub is amazing. And with Git to version those files with that local command is that it allows us to look at line by line differences. So this changed from master to main, and we can see this little part changed from this we added this refs heads to the URL for it to work. And then we can see in that conversation that the owner of this repo said, looks great, thanks for the fix. So that's how easy it is to participate in the open source community. And then what's cool too is that you see with insights, now contributors, I think I might even be listed here because I had this one tiny little commit that changed 2 little lines. So that's community and that's participation. and it's a lot to take in at first, but it's a pretty fun playground once you get going. So just wanted to share that as some encouragement. Okay. All right. So I'm going to move on now to manipulate. So this is lesson 2, and we're going to be using these R packages uh, to read in data and wrangle it, which is like import, um, tidy, and transform. Uh, and I like this as far as a background. You know, it doesn't sound very sexy to just wrangle data, but it is really critical. So this New York Times article, it's a while back now, 2014, said that the big data scientists, mostly it's janitor work. It's like you're just spending the large majority of your time collecting and preparing data before you can actually explore and use it. And so you look at something like, let's say, species distribution modeling, where you use a complex, under the hood maximum entropy algorithm to figure out, discern statistically the where you have observations of presence versus absence in all your environmental variables, and it then builds a statistical model to predict where your species can be. So generally, you have two functions. You have a maxent function which fits that model object, and then you have a predict function which looks at, let's say, a snapshot of all your landscape or seascape, um, and then predicts over that entire range. But those are the really like intellectually interesting part is just really 2 lines here. Those are the actual functions. And the majority of your work is wrangling that data into a table of environmental predictors and a table of the observations in the right format, and then a table of the new environmental data. And then once you get the output table, then wrangling that to any visualization or other summary product you want. So it's really, really important. And the easier this is to do, the more agile you become doing this type of work, uh, the more you're going to reduce the time to doing all kinds of tasks, because really this is the majority of work. And this quote is actually related, but from Tolstoy: "Happy families are all alike. Every unhappy family is unhappy in its own way." So this is true of data too. So Hadley likes to say this and pulled this quote. And tidy data sets are all alike, but every messy data set is messy in its own way. So what does that mean? What are we talking about? Well, it's really understanding that a tidy data structure, when you want to actually do a lot of the manipulations, means that each variable is in its own column. So whatever is actually varying between the observation is in its own column. But and then each observation is in its own row. So whatever is unique amongst your data, you want to put that within a row. And that's really, a lot of times you'll see a lot of columns that we'll work with today show up. Let's say we have year in one of the columns, and we have a whole bunch of variables that vary by year. Well, if we put those each in their own column, that's considered a wide format. And that makes sense for easily visualizing. It makes sense actually for manipulating between those variables if you wanted to take some summary statistic between them. But it's really good to know how to go between wide format and long format to use all the really incredible functions for summarization. So we'll go over how to do that. And this is different from using a base R, because there's R has been around since really the 70s, I think. And there's a lot of ways to slice the data and pull it out. But there's a logic, a thinking behind this that I'd like to go over. So we're using existing data structures, not trying to create too many custom objects. That makes it more portable for other functions. And we'll go over how to use a tibble and some of the incredible advantages of being able to nest any kind of data within a given cell, even another data table, even a modeled object. And then we're going to pipe these functions. We're going to, in a way where this operator, this pipe operator, so percent greater than percent, it's this thing that allows you to string or connect a series of analytical steps and then get your output. So whatever is on the left becomes the input argument by default of the function on the right. So if all of the functions you use expect, let's say, a table or a data frame as the first argument, you can now sequence all of those operations one after the other, and you can even put them on their own line. So the readability of your analysis is instantly obvious. And that it's not just syntactic sugar, it's not just syntax difference, really it's the ability to quickly understand your own code now and for your future self, as well as anybody else you're collaborating with. So you're not unpacking these really incredibly nested operations. And then functional programming, we're going to go over this a little bit, but the idea of using functions very flexibly with inputs and outputs, and even creating them on the fly, which we'll do. And the designing for humans is trying to use simple functions with verbs that you can easily read, and again, you can string along and have as a reduced a set of characters as possible to quickly do your work. And that also means being able to reference column names without even having to quote them. So you can do really rapid analysis, and we'll do this together. So there's a lot of R packages out there. This is just a small smattering. This is from R for Data Science that is along the lines of, it's like the Bible of doing this type of work for bringing in your data, importing it, tidying it, getting it in that format that allows you to wrangle it in any way you want, and then transforming it. And so with these programming steps, there's also, this is where you develop your understanding. And this goes back to even original R thinking, which is bring in your data, quickly plot it, look at outliers, maybe transform your data, model it, then maybe transform, model, and you iterate until you finally communicate out your results with a manuscript, with an online website, with whatever, like the Rmarkdown video that we watched last time. And so these are the sets of packages that do a lot of this work. And we're gonna, as we go through all the lessons, go through most of these. And today, I'm not gonna do too much on Reader and Read Excel, but those are worth checking out. Read Excel is for reading Excel spreadsheets, but we're gonna go over tidying and transforming and generally wrangling, as these three things might be considered, using this tibble data type. Really dplyrs the core function. Tidier helps you with tidying the data. We're going to nest the data, and then we're actually going to use functions to apply like a linear model to get a trend on some data. And then these are also worth referencing, that you can transform variables with dates, with strings, and you can rescale data quite nicely with these packages. And I can't emphasize enough just how incredibly useful these cheat sheets are, because it packs most of the functionality of these packages, and an R package is just a collection of functions that you can reuse, into some nice little visuals to get the gist of the data. And this cheat sheet has actually changed, but now you can see here's like a summary of the tidy data and how to reshape it. and I have references in the lesson to all the latest cheat sheets that are applicable here. So yeah, uh, this is the Bible, R for data science. Hadley, you generally end up Googling error messages and ending up on Stack Overflow. And without further ado, let's go to the lesson and talk about what we're going to do. So one of the integrated ecosystem assessment programs that I'm regionally that I'm working with is the California Current. And they've organized their data, especially Lynn DeWitt and others, on an ERDAP server. And if you haven't heard of an ERDAP server, it's an application programming interface or a consistent way to access data sets and then and transform them in these various formats. So we're going to actually pull from an ERDAP server a CSV file of some indicator data, in this case, fishing revenue, and a whole bunch of other anthropogenic indicators. And we're going to read that into a data frame. And we're going to use a base R function. So base R, meaning you get a bunch of packages in R when you install the vanilla install. And we can prefix R functions with the name of the R package and then 2 colons. So the utils package, which comes with every R install and is loaded sort of invisibly in the background, gives you a read.csv. So we're going to read that data in, and then we're going to show the table. So we're going to look at the table within RStudio. We're also going to render the table as an HTML, and then you'll see how even just converting it to a tibble makes it a lot easier to read. And then we're going to start in with the actual wrangling of the data. The rendering. By default, when you render a table, it just puts 2 little comments and it's just text. It's not very friendly to look at. So DT is an R package that took this JavaScript library called data table and wrapped a bunch of functions around it to create an HTML widget, meaning that it gives you interactive capability within a rendered Rmarkdown file for the HTML output type. And that allows you to sort on different columns interactively just from your rendered HTML, search for across any of the fields. And so that's a nice way to default render a data frame. And then we're going to wrangle this data with these packages. So dplyr, tidyr, and purrr. And we're only going over the most basic steps. This is really just giving you a flavor of what these packages can do. And then you can go to the cheat sheets, and there's a lot of resources. I add some resources over here in the main website, as well as further down on further reading. And you can select principally, and if we actually go and look at the further reading, which has this this data transformation dplyr PDF. So it just downloads as a PDF, and actually I already downloaded it here. And what I like is also these little helper visuals. So often, fundamentally, we want to select the rows. So I like this little visual where on the left we start with 3 columns, and then we select to get a single column. And then that's so column-wise selection, and then row-wise we'd want to filter. So the filtering then reduces the number of rows based on whatever criteria, such as a certain column having a certain value that you add there. And so that's like the most fundamental selection. And this is analogous if you have a background in standard query language, which gets used by databases. There's a select operator that this is nearly identical to. And then this is like the where operator in SQL. And what's also really cool, I don't go into this in this lesson, but as a side note, you can use all of these commands, and if you instantiate your table, there's actually a function called TBL or Tibble with a connection to a database and tell it which table you want, and you use all these analytical commands in sequence, it will, and then collect that at the end, then you can actually get all of it'll pass all the SQL to the database and then get your output. So these functions can actually act as a middle layer between your original data and your desired output. And you can even scale initially starting with comma separated value table as a symbol instance, then go to a SQLite, which is a file-based setup. And then you can go to like MySQL or Postgres or even BigQuery, and it allows you to ramp up to like bazillions worth of rows. And your analytical steps could actually, that code could be the same. It will transform it. Anyway, it's very cool. Don't have time to go into all that. I just thought I'd give it a mention. And yeah, so let's go back to the overall goals. So we're selecting columns, we're filtering rows, and then if we want to create a new column, we use mutate. And then if we want to summarize, so that would be like a group by function. And then so that's an aggregate function where we take a lot of rows and condense it into a few rows with some summarization. And then we can even do this thing of nesting tables inside of tables and creating arbitrary objects like a fitted linear model with this FIR technique. So this is just a small smattering of the techniques. And so let's get started by launching RStudio. And I think that you can do this at the same time as me talking about it. But this is being recorded, and we'll post the video within the next day of this recording, so you can go back and reference that. Sometimes it can be really hard to try to understand your code as you're pasting it in, getting it to work, debugging any problems, and then meanwhile I might have moved on to some other concept or some other line of code and instruction. So the best way, my recommended way, is actually to just give it a listen and then go back, read the lesson, and do it on your own after the hour, maybe while we're having some discussion, or later on your own time. And then you'll maximize your ability to follow the material. So, so yeah, you want to launch from an rproj file, ideally. So actually I have this thing open. I'm going to close this. And I'm going to I'm on a Mac, so I use Finder. I'm going to open up this. I have a GitHub folder with my username as the owner, basically. And then I've got my little R3 exercises. And inside here, you know, last time we created an rproj file. So you might not see the rproj extension if you're like on a Windows machine or if you have different settings, but it's this rproj file. What it does is, that's so cool, is when I double click and open on this, what it does is it opens to this working directory. So if I reference paths relative to this, so let's say if I want to list files in my data folder, this data folder here, it's always going to work. It's going to be relative to that, and it really helps maintain the portability of your entire repository. If you work in this mode, launch it this way, and that's also true from terminal. Like I noticed somebody said they couldn't find Git. Well, the .git folder was one of the messages I haven't responded to yet. Well, okay, so I'm inside the .git, so from a previous exploration. So pwd is the present working directory on my in my terminal, which is the file system, and then this is the R console. So this is an R commands get working directory. So that really helps to be in the same folder of interest. And now with this lesson, we're going to go File, New File, and we're going to create an Rmarkdown file for each lesson. And then we're going to go over the use of all these different functions and how they can interoperate with each other and look at some of these outputs. So I'm just going to call this manipulate and OK. And it creates this default file, but it's untitled still. So I want to go File, Save, or you can always see these shortcut keys with the command. So I'm going to save that, and I'll bump up, or I'll save it as manipulate. And I'll bump this up so you can see everything. And before I do anything else, I just want to share this other tip that I had in the lesson. So if you have version 1.4, I think, and higher, so you can check your version by RStudio, about RStudio, and 1.4, I think, and higher, then you get this other really cool feature, which is this visual Markdown editor. So Markdown is composed of front matter. This is in this YAML format, so it's just a way to set up variables. And then this is a chunk of R code, and it's being evaluated by R. And then this is Markdown. So this is a header. And then this is text. This is bold. And there's a cheat sheet to help you understand the Markdown. But you can also use this visual editor. And now we can just actually look at this. And so I can bold things here, or maybe italicize it, and I can create a new link like here, and then there's like insert link, or I can use the shortcut key. On a Mac, it's Command K, and then I can go to, I don't know, any URL. And then it makes that link. So this is a lot easier to edit Markdown. So I'm actually just going to delete all this, and we'll get going with this lesson by first going over to the California Current RDAP server. So, okay, sorry, before I do that, I'm going to do this. So I just deleted everything after this little setup chunk, and that just sets Knitter and Rmarkdown work together to render the Rmarkdown into HTML. And this is just setting a default option to echo, meaning show the code that you output, which for demonstration's sake we want to do. And then if I just paste this in the visual editor mode, then it's going to assume that that's code. So I actually, because right now I'm in a heading, I actually want to go outside of visual editor mode for this, because it's just easier to, now if I change back, then this is a header. It made that look like code because it used these little backticks, and I can start typing lorem ipsum whatever here, and that's just normal text. So there's a bit of a toggle here. For the sake of copying and pasting from the lesson, let's turn off the visual editor. But then for your own sake, in writing Rmarkdown, you would want to probably turn it on because it just makes it a lot easier to do it. And now that we have that, we're going to actually go to an RDAP server. And oops, I messed up the link here. So let me fix that. This is the actual link. So I'll fix that real quick. So That should be, oh, okay, because I forgot the HTTPS. Okay, sorry about that. So this is the training material site, and I just updated that. And if that takes a little time to update, I'll paste this RDAP link into the chat. Okay, cool. Okay, so if we search by CCIEA, which I mentioned in the lesson, we see all these California current IEA data sets with a whole bunch of indicators specific to the California current. And we can click on this data link, and this is this RDAP data access form. So there's a lot going on here. These are basically columns of different indicators, and then this is time. So you can filter by these things. And then if I just move all the time, then we see the data set starts in 1945, ends in 2020. You can scroll all the way down. And if I just use the default HTML table, I can submit and get this response back. So this is the data that we want. And we're going to just focus on some landing, the total fisheries revenue. And then this is Washington, California, Oregon, yeah, or coastwide. So sorry, landings. So here, these columns are Oregon, Washington, California, and coastwide. So we'll eventually focus on just those, and they don't really get going until 1981. So we want to eventually select based on those values, those columns, and then filter based on time. And to construct the URL to actually read the data locally, we can alternatively switch file type to CSV, comma separated value text table. So we switch to CSV, and then instead of submit, just generate the table. You'll notice that there's this really long string, but the default, this is all just query parameters in the URL specifying which columns you want. So if I unticked certain ones, I could do that. But really we want to know how to wrangle the data ourselves. So we're going to use, you could use RDAP to filter by time, and you could use RDAP to select certain columns of interest, but we're going to use just the basic URL to get the CSV output and use that in the next chunk of code. Okay, so we got that URL, and we're going to set variables. So this is just good programming practice. At the top of a given analysis, like an Rmarkdown file, you want to try to define the things that might change as a variable. In this case, we have a string, that's the URL, and we have a folder of data where we're going to download that into. So I can copy and paste this here into a new chunk. So this is Markdown, and the chunks of our code are these fenced brackets. But the quick way to enter a new chunk is here, just go, this little C is for chunk, and then an R chunk, or you could go to code, insert chunk. So if I do that, I get a little chunk of our code. This is telling it how to evaluate this chunk of code as an R set of R commands. And then we can run this here with this run current chunk, the little play button, or code, run region, run current chunk. And you also, again, see the shortcut keys depending on your operating system about how to run a chunk, even just with a shortcut. So for on a Mac, it's Shift Command Return. So I'm going to run this chunk. And what happened was, so data already got created from when I was messing around with this. So it was just a warning. And it downloaded it, so it overwrote that file that I actually did from last time, but it would be new for you, and it downloaded 53 kilobytes. So these are functions like, okay, we have this URL, this dir data, and we can go in and look at specific things. So if we look at the insidemost function that's operating on this line, I would start here. So functions are always parentheses with input argument. So the CSV URL, I can select that since I already ran it, hit and use command return to send just that to the R console, and we can confirm that that variable got set. I can use select this base name, command return, and now I can see, okay, base name basically stripped all the other stuff besides this base file name and gave me just that. And then dir data here is the data. And then so I can use those to construct a file path, which is where I'm going to want to download it to. So this is the CSV URL. That's the CSV. First we create our directory of data, and then we download this file. You can actually use, well, yeah, that's it for now. So now let's look at this in the files pane of RStudio. We can go to the more gear icon and then show folder in new window. So that's going to open up that folder that I'm currently in, and I can see I've got this data folder in the CSV. So in my case, I have Excel. You might have Pages or Open Office, Calc, I think it's called. But if you have some sort of program that nicely formats CSVs when they open, you'd see something like this. So there's all these columns, and we just want a few of the columns, and we actually want to filter the rows. So now we're going to start in with reading the table using read CSV. So let's create a new Rmarkdown, or a new section in our Markdown. So here we'll create a new, actually, subsection. So this is header level 3. And what's also cool is you see this guy next to that little button shows you the menu of the Markdown. So it helps us organize our content. And then I'm going to attempt to read this and copy and paste this in a new R chunk. So now I'm going to go new R chunk, so that little green guy, or you can use the shortcut keys, and now paste this, and I'm going to read this CSV in, and I'm going to run it. And the default here is to spit it out directly below that chunk. And then I can scroll through all the different columns. So the other way is if I did D down here directly in the console, it shows you the default R console way of showing this stuff, which is not very elegant. Yeah, we'll go over that a little bit more. This is what you should see if everything worked. And the first thing that we notice, and actually I'm just going to do a step that I didn't include in the lesson here, but convert it to a tibble. So convert to tibble so we can see more information that I really want. So I can just say tibble. I'll actually use the package tibble. And I haven't gone over this yet, but you can, if you don't have the package, you can go to packages and you can look for tibble. And here I see I have it. If you don't have it, you can then click install and then say just install tibble and install it, and you'll have it. And then you can run this function to look at it as a tibble. So it looks the same here, but also if I change it to chunk output in console under the gear icon of this Rmarkdown, that will, instead of in line, like in my Rmarkdown, in the console I can actually see a lot more of this at once. So I'm going to change that, and when I do that, I can remove that output there, And what it does is it actually changes this here. So, so these little guys, I'm gonna just add into, this is a little YAML. So just so you can see this thing, so this is not critical for you to do now, but it helps me explain what's going on. So a tibble will default this view rather than what we saw before and show you what type of data each column is. And then it shows you by default the first 10 columns and then says how many more, or excuse me, first 10 rows and shows you how many more rows. And then we see all the different data types and columns. And basically everything's a character because when we open this, the default for reads.csv is to take the first line as a header and then it presumes the rest is data. So the second line, we actually zoom in a little bit more, it's actually telling us the units. So what we want to do is handle that smartly. So this is what this next line does, is we can just insert this in here. And if we look at the read CSV, we can get help on this function. So I can type question mark read CSV and that pulls up the help. Or I can put my cursor over that function and then use the F1 key to pull up the help. And then we can look at this help, which takes a while to get used to reading the R help, but there's a lot of options. And then we see that read CSV is here and it defaults to headers true. And these are the other defaults. And there's basically a skip line. So we can read about these different arguments. And here's header saying true or false. Do we expect the first row to contain the field name? And then if we look at skip, we can actually, the number of lines of data skip before beginning to read the data and assuming what kind of data type it is. So now I can run this line and then I can look at the data. And if I change the data type again to a tibble and look at it. Okay, so we got a character for the first one and we got doubles for all this other stuff, but we still have 76 rows of data, which is actually the number we want. That extra row is just the units. And so that has the data, and then names is what allows you to read the names. So we can take the names from just the plain reads.csv with the header and then apply those to that data frame. So this is how you use names. So this is pretty much using just all base R stuff except for inspecting it with the tibble. And we can see now we have the names and we have double, which is numeric with precision, and we get all those fields back. So that got us to the point of actually getting the data table that we want. And now we're going to show the data table. So we're going to create another little header, so just Markdown, and then we're going to show the data table. And oops, so this is a chunk of R, and we're going to then run this chunk, and then we see that showing up here. So yeah, and so when I render, this is the interactive version, it'll show up there. Or I could just call the library, comment that out, call the library and show it. So we haven't gotten to the wrangling of data, and we're at the top of the hour. So I'm just going to go 15 minutes more and try not to go too fast, because this is actually where conceptually it's the trickiest, especially towards the end. So I'm just going to continue, and apologies if you have to go, but we'll share the recording. And here we can wrangle the data and manipulate with dplyr so that it corresponds with the sections here that in your document. And what we want to do is convert this to a tibble and transform the time, because the time is still a string. So we're going to use this mutate function to create a new column and or update that existing column in this case as date. And then we're going to select or limit the columns, and then we're going to limit the rows and based on the date. So if we grab this guy, paste that, so a new chunk. And now I can load these libraries. So go to packages install if you get an error message about the use of the library. And then we don't have to use the prefix for referencing the functions within that library, including this pipe operator. So here we take that same data frame that we had before and we pipe it into the tibble function, which gives us a tibble. So before you saw it as the first argument, and here we don't give it an argument. The first argument is fed by what's left of this pipe operator. So now we can see, okay, we convert it to a tibble. Now I can select this and mutate. So this now went to a date from a character. So it took a substring, and you can look at these little functions about how to extract the first 10 characters of a string, and then that pulls from the time field, and then it updates time. And we can then continue sequencing these operations, and we even use a special little function for all columns that start with total fisheries revenue. And we can see that, okay, now we have way fewer columns, and then we still have 76 rows. And then finally, we can limit the number of rows based on anything greater than or equal to that date. So in all, we get this data table that is much more manageable based on a subset of information of interest. Okay, so let's make it tidy now and see what that means. So we're gonna just paste that markdown header, and then we're gonna insert a new chunk, and we're gonna load this library, and we're gonna use this pivot longer. So that's going from that wide to long format. And let's see, I see somebody shared a good visual of wide to long. Yeah, so this is interesting. So the name here, so there's two unique observations per row here, and in the wide format. And in the long format, the unique observation by value is transformed into height and weight as an attribute column. So you'll see why this gets really useful in a second. But first, let's look at our original data frame. So we have the wide columns that is basically unique by year. And then when we pivot longer, this is another select operator that says pivot longer, but don't pivot on time. So use this data frame, and then if we look at the help on the function, saying which columns do you want? And this is a way of saying all columns except for time, because the observations are going to be unique by time. And what it does is it takes that column name and just creates a field called name, and then the value that was in that field, it puts in a column called value. Now you can change these defaults here to whatever you want, names to something else and values to, and set it to something else. But now we have um, a tidy or long form of this information. And you'll see why that's really useful next. So we can now we can summarize this information um, in a way that's much more intuitive. Um, First, let's say with these, really, we're just looking at data frame of total fisheries revenue. And each of these is a region: California, coastwide, Oregon, Washington, et cetera, and it repeats. So if then we can use this stringer package to help us replace that string with nothing. So we are only left with the region, and then we can select time, region, value, meaning we drop that name column. So let's do that. So I can look at this mutate step individually. Let's see, did I run? I can run everything up to where I was, and then gives me a nice fresh D. So I have time, name, value, and then mutate is going to then create a new column called region based on the name column, and we're just going to replace this string with nothing. So let's see what that looks like. Oh, could not find the function string replace because I hadn't run the library stringer. And you can always also find out if you have the library loaded what library it comes from, because at the end it tells you the environment namespace is stringers. That's the R package. You can also find it here when you go to the function. It tells you the package name right after. Or if you haven't yet loaded the package, like I know it's called string replace, and let's say here I have stringer, I'm going to detach or unload that package, and now I'm back to couldn't find it. I can actually do 2 question marks to look through all the help for string replace, and there it finds it. So anyway, okay, so we can look at this now that we've loaded the package, and now we get so we still have the name column, but we have this new region, and then we can select time, region, value. So we drop that name, and now we have what we want. So this is just prep work for finally doing this, summarizing by region. So when we group by, that's from dplyr, it tells us the groups. So there's 4 regions, and then it hasn't yet, we still have 160 rows from going into the long format. And now we can summarize, meaning then define a new column like mutate, but aggregated based on feeding this function mean all the values for the given region. And when we do that, now we get this nice table, dsum, of the regional average revenue. And we can output that table and see here, but we know that it's in dollars. So DT has a function called format currency and other formatting functions, so that that can also display as dollars with cents. Okay, so I'm just gonna continue on here with the last and trickiest but coolest section. So we're going to apply functions with per on a nested tibble. Whoa. Okay, so we create a new chunk, and really before we run this, let's go back to the documentation. really here is the motivating um, question for this analysis, which is what's the trend over time for fishing revenue by region? And this is where we can take advantage of the power of Tibbles and the fact that they can have this thing called a list column. And we can, after we group by, we can nest all the data into its own column, meaning each region can have its own tibble within a tibble. And then we can actually run a linear model on that with this per library, and that's where it gets a little hairy. So that's where we're going to get a trend. Okay, so let's just run this. We're going to load this per library, and there's again a nice cheat sheet on this that I linked to, and it's here, and we're doing this nest step where we're taking a bunch of content and then nesting it into a grouped by value, and we'll see what that looks like in a second. So I'm just going to call this N for nest, and when we group by that original data frame, it's still the long format. We're going to group by region again, so we have 4 regions, and then we're going to nest, and we're going to create a new list column called data based on concatenating the columns time and value. And then let's take a look at what that looks like. So this is a tibble with a tibble inside of each cell in this list column. So that's where we've summarized the data. Now, the reason we want to do that is we're going to take advantage of this by generating a linear model per region of data, and that's this LM function. So that's part of the base stats function, and we're going to get the value over time. So the formula comes first, and then the data, and we're going to feed it this data, and then we're going to also mutate. So we're going to create a new column, LM, the linear model, and then we're going to extract, so mutate happens in sequence, the trend from that linear model by feeding the linear model value into this anonymous function. So I'm going to do this so you can see what it looks like, and then I'm going to get inside of it so we can talk about how it works. Okay, so there it is. We have this tibble that is the original region and data, and then we have a linear model, and it just shows up as a list column again, and that's the actual fitted model object. And then this trend is double. So map, it's not like map is in a spatial map, but it's more like map is in a crosswalking of one thing to the next. So map takes the input of data, and then the second argument is a function, and it always returns a list. So we know we're going to get a list object back. But if we want to get a double, then you would use map double, and you have these other data types, and that gives us that back. So let's do this browser function so we can see what happens inside here. So data here is a column, and what happens when we take this original, let's say we're back to N, have just this data column. Now what happens when we run this again? And now I'm just selecting, I'm not assigning it. Actually, it doesn't matter. You'll see what I mean. With this browser function, I'm inside this anonymous function, so it's not a named, it's anonymous. And it has a function and a D. So this is the first argument in, and that D is what gets swapped out for whatever that value of the given cell in the data is. So if we look at D now, it's that region's data. And so it has time and value. And then this is the formula to spit that out, so let's say we call this M, and now we look at M, and this is the linear model, fitted linear model. And then if we can just run this guy to see like, okay, what are the bits of that? So like, what is summary of M? Well, you get this nice summary. And then if you just want the coefficients of that fitted model, coefficients, and that's really a matrix. So I can say the first row I want is time, and the first column I want is estimate, and that's a way to slice the matrix. So now we get everything we want, so I can stop that. That was just to get you inside the function, to browse inside of it, and a function is defined by input arguments inside the parentheses, and then expression or expressions inside the curly braces. So I could have also named the function and been like, okay, get lm, and done this, and then I can just say get lm is the second argument. So this is functional programming and the beauty of using it. So I say get lm, and then I run this, and I get the same thing back without errors. So I know that's a lot, but it's very cool, and it takes some getting used to. I encourage you to try this with a different data set or different columns from the data set I pulled on the ERDAP server from the California Current. And I will, follow up with expanding this to even more goodies. I really want to talk about all these other learning objectives, but this was already enough, like using APIs and showing you how to arrange and pull values and joining tables and actually creating a relational database and showing you those concepts. But I will expand this just for your own benefit, but this is what I think is doable within a relatively short period of time to copy paste. So I think with that, I will pass it back to Kim, and who can help direct me towards questions and comments that you might have added in the chat. Yeah.
Yeah, definitely. There was a little bit back and forth, but it looks like a lot of people were answering each other's questions and stuff in the chat, so that's awesome. The last one here is, what is the advantage of map over loops?
Yeah, so the advantage of map is that you could be within this continuous like analysis framework. So I can do all of this, for instance. It's a good question. And at first, well, let me show this analysis with a loop. You have to do a lot more bookkeeping, basically. So if we just have like the base n, so now with a loop, so we're back to our simple n, and let's say we would say for I in 1 to n row of n, and then we would say something like, okay, make this anonymous, or just go back to the original format up here. And so, and then I'll just message so you can see which eye we're on. And I'll also use this cool glue function to show us which eye we're on. So this is going to loop over each row. So we're on I 1, 2, 3, 4, and then we can do this thing where we could say, okay, give me the linear model. So give me the data is then n data and maybe the ith one, and then I can do the linear model on that data. So I could do it like this. So n of lm, but of that ith. So let's see, does this work? Ah, n data I. Oh, so I have to reference in the interior contents of it, not the reference to it. And so we have to instantiate n lm is a list. Actually, I don't know how to do that. I don't know how to create a list object. In a data frame. So if I knew how to do that, then I could answer your question. But there's basically a lot more bookkeeping. So you have to iterate through all the rows, keep track of the row, and then assign objects. Whereas this, you can have all of your, like I could have just continued to rock on here, and then you have your analysis. Because it's tidy, I can just keep on iterating. And by mapping, I can mutate on that column. So it's just an easier way of iterating rather than doing the for loop. So, I'll think on that question a little bit more, but once I figure out how to create a list column type. Yeah.
Looks
Oh,
like we,
yeah.
sorry.
Okay.
Looks like we have another question. In this example, it's simple enough to fit linear models to the wide version of the data. What do we save by doing it the way that you showed?
Yeah, well, the summary part is this is where grouping, like you could have summarized with the original wide version, but then it would just be per column, and it wouldn't tell you the region. So we're getting the unique values in the long form by what they're unique by. So the original had total fisheries revenue, and then there was actually a piece of information that was the region that was buried in the column name. And we extracted that, and then by having it long, showing all the things that varied by row, which are region and fisheries revenue, then we can do this group by region and summarize. So that's a trickier thing when you're handling it column by column, because you don't have what's varying by each column as a unique value, because it's just smushed into the column name. So we got it long to, similar to that other example that was shared, of there's really extra information in the column name that we extracted as similar to an extra attribute, that we can then group by on region and use these more traditional methods. So in this simple use case, it's definitely, it's not as obvious. These are really good questions. The tremendous advantage of going with this approach, but I'll try to supplement with beefier examples where it would be nightmarish to continue to handle the wide format and show the the difference between the two. I think those are two great questions that I want to elaborate on with examples.
Awesome. Looks like there's another one that's more a styling question. Why do you indent after some functions in your dplyr chunks and not others? E.g. line 112 chunk where the mutate is indented but select isn't. Is this just a styling thing?
Okay, yeah, thank you for asking that. So it is a styling thing. It's my preference. There's this could look like a lot of different things. And the reason that I like this, especially when I go wide like this, is that when I read down, and you see this even more here, this example, when it's those two operations above were lumped into one, I can read down, I can see by the first line that I'm inputting this D tibble or data frame. And then the first step is it's grouping by this region, and the next is it's nesting. Well, what is it nesting by? It's nesting by data. So, or in this case, here it's mutating by region. So, or it's mutating, creating a region column. So the indentation is easier for me to process because it's saying, okay, here's the new column that mutate is operating on. And sometimes if I have a lot of fields or they have different sort of, importance with my analysis, I might do this. I could have just done this, and this is totally fine. And then you just see that, okay, we're just mutating and then we're selecting. But I personally like to indent because I find that I can read down to see what's the sequence of operations, and then I read in to get the details on that operation. Similarly, here I'm grouping by and then nesting, and here I don't indent. I could have, but it's just one field. And when it gets a little bit more complicated, I tend to indent. And then here, I indent on this, even though I don't have to, because this is specific to creating this LM operator. And whatever is the last function call within a function, that's the output value that spits out. So yeah, that's just a personal preference. Yeah.
Looks like one more question. Is it also easier to comment out portions of code when you create a separate line indented for rows?
Oh, that's a good point. Yeah, exactly. So now because it's indented, I can do these things like I can say like, oh, here we're gonna get a linear model, and then in an anonymous function. So that's actually a good point. And then we're gonna get the trend from the model using base using stats functions to extract coefficient. Exactly. So that it's all about readability. And when you become more familiar with these functions, they just become more transparent and readable right away. And then these comments actually start getting in the way because you can kind of you read that language. Yeah.
Thank you. It looks like we're right at the end of our time.
Ooh.
So I will copy the chat into the notes. And I just wanted to thank everyone again for coming. And the chat's always such a fun thing to follow because everyone's popping in notes and links and stuff. So thanks so much, everyone.
Cool. Yeah, thank you all so much. And I hope to see you next time. Stay tuned for more updates on this too. All right. Take care, everybody. Thanks.